As part of the linked list programming, single linked list, we have done with creating a node, insert node at beginning, insert node at end, and particular position, and of course the display also. Now we will see this delete part. So delete at beginning, delete at end, and delete at a given position. How to make it? We'll continue the program where we left actually. In that we'll add the functions, all these things. Hello everyone, this is Shravan Kumar Manthri. Welcome to our channel CSE Gurus. So here what we have done, you can see we have done with creating a node, and we have written till now 6 options, which is creating a node, inserting node at the beginning, display, inserting at the end, and inserting at a position. Now our task is to make it how to delete a node at the beginning. First of all, we'll make it. I'll write a printf statement here, the choice number which is 7, where I'll give it as here 7, option 7, which is delete at beginning, so which is the first node to be removed. So that is what we'll do here. So for that I'm writing the switch case 7, where when you want to delete it, no need to give any input parameters, directly whichever is the first, that has to be deleted. And I'll write delete underscore begin, the function name, delete underscore begin directly, no need to give any input value. So directly which is the node at the beginning will be removed. So this is what I'll write initially, and then I'll write the function here. I'll try to, so void delete underscore begin. So directly, yes, I want to write it. So how to make it? Point number 1, we have to write like, if there are no elements in the linked list, what you need to do? If there is no elements in the linked list, yes, we know that the condition is if that is head node. What is the head node? If it is null. If there are no nodes in the linked list, you can directly say that list is empty, right? So that is what I want to write here first. If head equals null, that means there are no nodes in the list, so the list is empty. Else, yes, there is at least one element. What you need to do, that is also very most important. If at least one element is there, what you have to do? If more than one is there, that is also we have to make it. And this is very important. If at least one element is there, let us suppose I want to write like this. So there is a one node in the linked list. Assume that this is 1000, this is null, and the element is 20 here. Here it is 1000, which is a head node, and this is head value and tail value, right? So head and tail both are equals to 1000 now, which is a head node and tail node. Now if it is a one node, what could be? If I delete this one, means what? Your head value should become null and tail also, both should become null, right? So that is what you need to write first. I'm writing that first. Here you can see, else if, how can I say that your linked list have only one element? If it is 0 elements, means yes, definitely head equals null. What if it is a one node? I have two things you can write. One is, if head of next is null, means yes, only one node is there, or head equals to tail. In that case also I can say there is one node in the linked list. It's up to you which one you want to write. If head of next is equals to null, yes, that is also correct, or head equals to tail, means there is only one node in the linked list. So I'm writing like this. If head of next I'm writing is equals to null, means there is only one node in the linked list. What you want to do? If it is, simply you have to make what is head, what is tail, both will become null directly. And also one more thing you need to remember, you have to free up the space. Anyway, head equals null, you kept it. Whatever the node is created, that node you want to delete it, right? This node has to be deleted. Now how to delete it? Anyway, there is a function called as free. Of course this is optional, but you have to make it technically to be correct. When there is no node is required, when you delete, means the memory also you need to delete. In that case, if I write here head equals tail equals null, means your head value is not available here in order to delete that memory. The 1000 value is not available. Before that, can you do? No, right? You cannot free up. So that's why I'll take here as a struct node not to traverse, struct node temp, not to traverse actually, to store the address of the first node. So temp equals to head. Now after this line number 117, what is the answer here after this? See, previously temp equals to head, temp equals something 1000, head equals to 1000. Now after this line, after making head equals null, of course tail is also null, but temp is 1000 only, which is not updated. So after this I'll make it as free of temp. This is the one thing you can make it. Free of temp means yes, that our address which is null. This is the one thing you can do where there is only one node. Now else part, there is more than one element in the linked list. Okay, it's not 0 elements, it's not one element. What if it is more than one element? How to do it? We'll make it. Now you can see here 2500 means this address which is the first node, and here 2000 is the next node. That's why here 2000, here 3000 is there which is connected. This is 3000. Now I want to delete the first node, this node. Means what? Your head value has to be changed to this node. How to make it? What is the statement you have to do? So that means head value is equals to, can I say head equals to, what is anyway, head is 2500, anyway tail is here. So head equals to, can I write it as head of next? I think the answer is over. Why? Because what is head? 2500. Head of next 2500 to the next 2000. So that 2000 I am keeping here. That means your first node now is head value is 2000, means it's not connected to this, it is connected to this, so that this is the first node. Anyway, the remaining elements and tail also nothing to update, right? So this is what you can do, and you have to free up this. So anyway, that value is there in temp, that's why you have to free it up. That is also, you can write it here. You can see the only one statement you have to write is head equals to head of next. How simple it is, you can see. And you have to free it up the temp, which is the temp which is stored in the head node. What is that address? 2500 previously, which is that will be deleted memory. See how simple it is. Is there any loop? No, there is no loop, and directly you can take the first node, and that is the answer. And the complexity is only big of 1. There is no n complexity here when you want to delete a particular, I mean it's a first node, which is the first node in the linked list, right? So this is a simple one. Let us see whether we'll get the answer or not for this. Any errors also we'll check it out. So first of all, we'll create the nodes 20, and I'll insert at the beginning 10, and I'll insert one node at the end 50. You can see the display part. So 10, 20, 50. Yeah, I'm inserting one more node at the end. Let us see. Option 5, 60. Yes, you can see the display part. Now if I go option 7, deleted beginning. What is the node at the first? 10. 10 has to be deleted. Yes, you can see. Anyway, I'm not printing that. You can print it also. But anyway, you can see the display part. So 10 is removed. If I go again, yes, 20 will be removed. You can see the display part. 50, 60. Now if I go again with 7, yes, that 50 will be deleted. You can see 60 is there. Now you want to insert one more node. Let us suppose at the beginning you can insert. You can make it parallelly, right? One by one in the sequence. Yes, the display part 30, 60. If you want to delete it, yes, 30 will be deleted. You can see. And you want to delete that node also, yes, you can make it. One node is there, you can make it, and you see the display. Now there are no elements in the linked list. Yes, list is empty. That is what if no node. Now still you want to delete it. There are no nodes in the linked list. List is empty. It has to display. Yes, without any error, it is displayed. And one more thing you can update here. If you want, you can make it here like here. What is deleted actually? That is also you can make it here. You can write printf %ld deleted. What is %ld? Which is temp of data. Before freeing up the space, before deleting the memory, I am printing Once you printed, I am deleting that memory. So the same thing you can write. Anyway, you can write outside also, that is also absolutely fine. But if head is equals null, in that case this is also trying to implement. But anyway, you can make it some return statement here, that's not a big deal. So now you can see the output. If I write 1 to create it, 20, to insert 30, to insert 40. Now you see the display part, 40, 30, 20. Now if you delete at the beginning 7 option, it will be displayed. Yes, 40 is deleted. Now you see the display part, 30, 20. So now 30 deleted. You see the display part, 20. Now 7. 20 deleted. Now you see the display part. List is empty. Anyway, if I still go for 7, yes, it says like list is empty. You cannot delete, right? So this is very simple, like how to delete a node at the beginning. Now those who are executing in live, you can check it out clearly and you can execute. Now going to the next one. That delete a node at a particular position. First we'll do delete a node at the end. After that a particular position will make it now. So first I'll write here the option 8, delete at end means the last node. Whichever is the last node will be deleted at the end, and which is a case 8 I am writing. Case 8, delete underscore end. No need to give any input parameters. Delete at the end and break. So can you get the answer with one complexity? Definitely not. I'll tell you why. Okay. Yeah, here I'll write void delete at the end. So here of course the same thing you can make it. Here you need to create a temp. If head equals null, list is empty. Head of next is equals null, the same thing you can make it. So that's why I'm copying here. Why? Because even if the one node, you have to delete that node itself, beginning node and ending node. So that's why here I'm writing the same thing. So head equals null. If the list is null, list is empty, you cannot delete. Else if head of next is null, so head equals tail equals null, that is also fine. Else if there are more than one, what you have to do, that's what we have to do right now. If you check it out, 1000 is there, this is a head node and this address should be 2000, so that it will become the second node, and here 3000 and here null. Now what is in last node? 30 has to be deleted. Your head is here and tail is here with this address. Now can you make it tail means can you come back? Actually if you delete this one, tail has to come here. Is it possible to come back? Of course, even it is a single linked list. Can you come back? No. In the single linked list always you can go forward, right? In the single linked list where you can go forward always, which consists only one node. So that's why you can go forward only, you cannot come back. So always you are moving one step forward in the single linked list. Now can you come back? No. So that's what the problem you cannot get with the one complexity. You have to traverse the temp variable. So temp starts from here, you have to traverse, and when temp comes before the tail, so temp should be here, then I need to start the process. Now temp is here and tail is here. What you need to do? Now when you temp is here means temp is 2000, temp of next is through 3000, right? So now what you need to do is, what is temp of next? 3000. What is tail? 3000. Now I'll make it temp of next equals to tail, then I have to stop. Temp of next is equals to tail, then I have to stop there, and now I need to stop, get the process. So what is temp? Temp of next is equals to tail. So then that means that yeah, temp is here, tail is here. Now what you need to do? This has to become null. So temp of next should become null, and then temp of next should become null. That means here null should be there, so that it will be disconnected, and now this temp should become now tail, right? So new tail will be now what is the temp. So these two statements are absolutely fine, and anyway we will make it. Anyway, temp has to go till the last, while temp of next, if it is equals to tail, you have to stop. Means if it is not equals to tail, yes, you have to move your temp value. Temp is equals to temp of next. You have to move it, and temp equals to temp of next. So once you get temp is there, when you stop, two statements are there. One is temp of next should become null, and now the next, what is the new tail? New tail will be now equals to temp. Whatever the temp is there, temp you have to make it. That's it. Anyway, you have to free the memory. Which one to be freed? Tail. But tail is now not available, right? So that's why you have to make which one to be. Temp has to be, temp is nothing but the current one, which should not be. So tail has to be removed. You can write it as free of tail, and then tail equals to temp. That is also you can make, or free of, what is temp of next? 2000 to the next, which is null. It is there. So that's why I think we have to make like free of tail. What is tail now? The last address, which is 3000. We freed it. Now what is tail? Now we are updating, which is our temp. What is temp? 2000. We can make it, right? Let us see what is output, and anyway here also we'll print it. What is actually deleted? It's not temp of the data, it is tail of the data, which is removed, which is the last node. And after that free of tail. And what is tail? Now updating, which is temp. So let us see whether it will execute successfully. So 1 for creation, 20, 2 which is 10, and 5 at the end, 40, 5 at the end, 50. I'll go for display. So 10, 20, 40, 50 we are making. One more element if you want. Yes, you can make it at the end, at the beginning, or at the end, or at a particular position you want to make it. Yes, you can make it, which is option 6. So where you want to give, I want to give the value 45 at a position 2. Yes, you can see the display part, absolutely fine. Now you want to delete a node at the end, which is 50 has to be deleted. Option 8 I'll give. Yes, you can see 50 is deleted. You can see the display part. So 10, 45, 20, 40. Again you can delete. Yes, option 8. Yes, 40 is deleted. So now you can see the next one. Again I want to delete. Yes, or else you can go for delete at the beginning now. Yes, why not? Option 7, 10 will be deleted. This is the display part. You go for delete at the end. Option 8. Yes, 20 is deleted. Only one element in the linked list. Again you delete at the end. Whether it will work it out. One node. Yes, perfectly fine. The display is empty. Still you want to delete. Option 8. Yes, it says list is empty. So this is what you can make it. And anyway, 4 for exit. Yes, process completed. So this is what deleting a node at the end. Like this you can write. Now those who are executing, they can see here and they can execute step by step how clearly you can make it. Now moving on to the next one, option 9, deleting at a particular position. Let us see how we can delete at a particular position, given position. So option 9, delete at a position, and we'll see what is the output. First we'll write the code. For that case 9, I have to write it here. I'll directly call, but here you need to provide the position, right? So you need the input printf enter position to delete, right? Enter position to delete. So I'll write here scanf. Anyway, I'll take the same variable, position variable. Why should I take the extra variable? We are written separate case values. So now the function delete underscore position, I'll write POS or position, where you need to give the input, which is POS, and of course followed by break. Now we'll see this one. I'll try to write the code, and I'll give position as P here. Now the same things which you need to do. First one, struct node temp, you need to take head equals null, list is empty, and according to the position which we need to make it. So here it is 1000, which is the first node. I'll take the values 10, 20, 30, 40. Anyway, the last node is null, so this is connected, so that's why this is 5000. This is connected to this, that's why 2000. This is connected to here, that's why 3000. So like this, the nodes are there 10, 20, 30, 40. Now I want to delete a node which is at the second position or third. This is the first, second, third, fourth. What if I want to delete at the first position, means deleting at the beginning. What if it is the last position? You have to delete at the end, right? So it is middle. What you need to do? Let us suppose I want to delete this one. Let us suppose your temp is here. If I want to delete this one, means temp of next should become what? Temp of next, what is this position? If the temp is here, I'll come to the position. Temp is here, and what is the temp of next? Actually 3000 should become this one. I'll take another variable where this is temp, this will become, if this is temp, this will become temp1. That means always traversing with the previous two nodes I need to traverse. If this is temp, this will become temp1. So in that case, what happens is, if this is temp1, so T1 of next, which is equals to temp of next. That's it. That will be the answer, right? So that you can do. Let us see how you can make it here. Else, of course, the first thing, if it is a first node, there is no chance of making like this. Else, if the first one, if P is equals to 1, means what you need to do? You have to simply execute delete underscore begin. Okay, else, if it is not a first node, now we are traversing like this inside. Okay, now we need not only the temp, and we need temp1 also. I'll take pointer temp1. No need to initialize this one. I'll tell you why no need to initialize. Yeah, I'll write here, you can see temp1 there. And now else, you have to go to the position. Okay, you have to go till the position where, for going to the position for I equals to 1, same like previous, I less than, so I less than P minus 1, I plus plus. If you want, you can trace it clearly why we are writing this. You are checking like if that is a node. Let us suppose if this is a node which you want to delete. If this is a node which you want to delete, temp should be here, sorry, temp should be here, temp1 should be here, right? So let us see this one, whether we can make it or not. So initially temp1 is equals to temp. What is temp? Is equals to temp of next. So this is what we can make it. So temp1 means, which is a previous node, will become temp equals temp of next. Like this it will go. Let us go with one example. If it is a third node, if P equals to 3, so I starts from 1, temp1 will be here equals to temp, yes, temp equals to here, fine, temp of next, yeah, next I equals to 2, 1 means 3 minus 1, 2, fine, I equals to 2 is less than 2, no, you have to. So one more thing you need to make it, instead of I less than P minus 1, one more step you can make it, that is I less than P. That means you can go for, this is T1, this is T, you need to make it. Now once it is done, what is the thing you need to make it? So that is the one thing I told you, like your current T1 temp1 of next should become temp of next. So that means if suppose if I want to delete this one, so here the address will become, instead of 3000, 2000, you will get it. So this is a connected. I think only one change you can make it, and you have to delete this temp which is there. Remaining things are unchanged here. So that's fine. Here I'll write, of course we'll make it first printf %d deleted, which is temp of data, then free up that space which is temp. Now what if you want to delete the last node? How can I know that this is the last node? This will work even if it is a position is the last position. Let us see. If let us suppose this is the last position 40, T1 he will be here, T will be here. I am writing, you can see. This is T1, this is T. So T1 of next, what you are doing, temp of next, which is null, you are keeping here. Absolutely fine. %d deleted, which is temp is deleted, and free of temp. Yes, absolutely fine. And one more thing which we need to make it here is tail has to be updated. That we forgot. So that is, we'll write it specially before deleting that. If let us suppose what is the temp is the current node of next is null, is equals to null, what you need to do is our tail has to update with T1, which is temp1 should be our last node. Anyway, you deleted the next, that's why tail has to be the last node. That is what you need to make it update. I think that is absolutely fine. Anyway, free of temp, that you can make it. Let us see this output. Anyway, the variable I to be declared. We'll see the execution. I'll take the elements 20. Okay. Yeah, option 2 might be 30. Option 5 might be 40. I'm entering the elements. Option 2 might be 70. Option 5 might be 60. So the display part you can see. These are the elements. Let us suppose I want to delete a node at the position 4. Yes, 40 deleted. You can see it's perfectly fine. Now you can see still if I give 4 option, which is 60, which is the last node. Let us see. Option 9 first. Option 4, still it is deleted. Yes, you can see, yes, perfectly fine. It is deleted. Now you see the display part like this. Let us suppose I'll give option 9, where it is a first node to delete. Is that 70 is deleted? Yes, perfectly. So 2 elements are there. So when you want to delete again the second position, which is the last node, yes, perfectly fine. You can see it is deleted and the display part is static. Again I'll give 9 option, only one element is there. Option 1 I'll give 1 position. Yes, that is also deleted and you can see the display part. Even if I give 9, it is asking the position, but is there any element? No, list is empty. So like this you can make it easily how to delete the elements at a particular position. So those who are executing, they can see, they can execute. So now we are done with delete node at beginning, at the end, at a given position. So we'll see count how many nodes are there and how to search an element in the linked list in the next video lecture. Thank you.